Yeah, hello everyone, welcome. Today I will be presenting our project in Chainway. We call it the Proof of Innocence, and I will be speaking about the next steps of Proof of Innocence actually, the mathematical compliance. So let's start with me. This is me, yeah. My name is Orkun. I'm co-founder at Chainway. Chainway is a Web3 venture builder based in Istanbul here, and you are all welcome here. So previously I was working in DeFi and stablecoin industry. Then I co-founded my company, Chainway, with my dear friends. Now we are working on zero knowledge, DeFi and infrastructure stuff. These are my co-founders. They are not here. They're in a conference in Montenegro and Austin, sadly. But today I will be talking about our project. Thank you for the previous talks. Now I will talk about the privacy, but on-chain privacy, and how we can get protected from attacks to on-chain privacy, actually. Let's start with this. We know that privacy is a right? We talked about this a lot. But there are different levels of privacy. For example, in traditional systems, you have privacy in terms of other users, but you don't have privacy to regulators and banks, for example. In your bank, you have privacy to other people. They don't see your bank accounts, but regulators or banks see everything about you. In blockchains, you have something we call pseudo-anonymity. So you are anonymous until the point that you connect your account or you connect your off-ramps, on-ramps together. Until that point, you are not anonymous. And you are now, this time, you are public to everyone, in fact. And there is next step, ZK blockchains and applications. In the ZK blockchains and applications, you are fully private. That's a good thing. But being fully private is not the solution. Because if you be fully private, then you will be hard time proving yourself to the maybe regulators if you want to be compliant or maybe another parties. So yeah, there's different levels of privacy. There's default privacy, the two versions of default privacy actually. One is not auditable and the other is auditable. And there is something we call optional privacy. So let's get into the details. Okay, how to solve it? To me and to Chainway's vision, we really want that we should have default privacy. Privacy shouldn't be optional. Why? For example, Tornado Cash was an optional privacy tool, for example. But if you use Tornado Cash, now you are sanctioned by the US government or US regulators. Okay, if you put privacy to optional position, then it will be get minority, and then regulators will start investigating and talking about you. This is my view. So what we want optional auditability through privacy preserving methods. Why do we call privacy preserving? Because, for example, if you just reveal your addresses to regulators, okay, you become compliant, you are still private to the on-chain parties, but now you became something like bank user. So we don't want that. We want to protect our privacy, and we also want auditability. So these are our solutions actually. We do exclusion proofs on private blockchains and applications. So exclusion proofs also, we can say that it is a non-membership proof. So it has some points. For example, there is no system admin, no master viewing key. So you are still owning your data and protecting your data. And you are excluding yourself from a given list of commitments and accounts if you want to be compliant. So instead of giving your details to the regulators, you say that, okay, I am not one of these ones. So by exclusion proofs, you prove that you are not criminal, but you don't have to say your identity exactly. This is the solution that we came up, and we call this mathematical compliance. I think it's a cool name, and it's suggested from Railgun team. Let's get into the technical parts. So Proof of Innocence was our first product on Chainway. Actually, Proof of Innocence is a public good. Let me get into the details. It is built on Tornado Cash. I think we all love Tornado Cash. But unfortunately, right now, it is a little bit hard to use. Or if you use, you will be having hard time. Exclusion proofs are hard. This is a technical topic, but exclusion proofs are not easy to implement as inclusion proofs. On-chain, for example, when you are withdrawing from Tornado Cash, you just easily prove that you are in the Tornado Cash because of inclusion proofs. We call it membership proofs. But if you want the exclusion proofs, then it is hard. If you want on-chain provable exclusion proofs, it is even harder. Because yeah, it is too much technical, but if you want to exclude from some list, you have to give that list. And if you give that list, it will be expensive in terms of gas. Maybe it is not, the block will not have enough gas to cover your details. Yeah, this solution. And this overall schema is just talking about proof of innocence. For example, let's say in Tornado Cash, there are 5 deposits. 2 of them are coming from hacker's account. And 1 of them is yours deposit. So you withdraw from Tornado Cash regularly. Then, for example, US government came and say, okay, you might be hacker. I am banning you from all centralized exchange or from all off-ramps maybe. Okay, you are not hacker, you know that. You want to prove that you are not hacker, but you also want to keep your identity to yourself. You don't want to reveal your account and connect your accounts to the US government or US regulators. So what we do is, while you are withdrawing, we prove that you are excluded from a list of commitments. It is, again, technical, but we construct a sparse Merkle tree of exclusion list. Exclusion list is like some array, some list, a list of commitments, but we put them on sparse Merkle tree. The sparse Merkle tree solution here is for us actually for scalability, not privacy. So we create a tree of commitments. Then we publish that list to the IPFS, aka PermaWeb, because if we push that to on-chain, it will be expensive. So we are just pushing exclusion list to the PermaWeb and pushing a route to the on-chain. So anyone can connect these two and create your exclusion list. Then after that, in a ZK circuit, we prove that your deposit commitment is included into this list. So by this ZK circuit, you are now fully compliant in terms of our view. You are fully compliant to the government because you say that, okay, my withdrawal is not related to hackers' deposits. If you prove that, okay, then you are safe. You don't have to reveal which address you have. You just prove that you are not hacker. And you do this with fully private methods. Everything happens in your local. You just push proof to the on-chain or give it to the regulators. Then they can verify it on-chain or they can verify themselves. Yeah, you prove that you are not hacker without revealing your identity. Okay, what are we planning next for proof of innocence actually? Until that point, things were, I shouldn't say simpler, but if you see these, then yeah, we can say that this was really simple. So next steps, we received 2 grants, one from Molokda and one from Railgun DAO. So we will implement these 2 cases. Case 1 is Tornado Nova. Tornado Nova basically a new version of Tornado Cash that allows you to deposit and withdraw arbitrary amount of any token, for example. You can deposit just 1.3 ETH if you want. And you can withdraw just 1. Okay, this is a nice feature, this is UX friendly, but it makes our job harder because now we have partial withdrawals, partial internal transactions actually. It makes our job hard. Okay, the tree in the Tornado Cash Nova is complexer than the tree in Tornado Cash Classic. Because the leaves of Merkle tree in Tornado Cash are just commitments, but now we have UTXOs in the leaves. So UTXOs are not easily provable compared to the other things like commitments. But if we want to solve it, we need recursion because withdrawals are partial and we need to partially withdraw a chain of commitments. So we need recursive, all folded proofs actually, but they still need to be on-chain provable. So they still need to be succinct and small. Yet this is the case we want to achieve actually. The Railgun is really similar to Tornado Nova. They have some additional features like swaps. You can privately swap your tokens. And this is another case like using UTXOs, and it's a little bit complex than Tornado Nova. But we still need the same properties, and it is still hard. But we are making progress, and I believe we will be completing this in the next 6 months, actually. Okay, so now I think we all agree that every system requires some mathematical compliance. If we compare compliance to the mathematical compliance, if we need one, we should choose mathematical compliance, we believe. So we are right now working to create the most efficient exclusion proofs. For complex systems, this is not just ZK applications on Ethereum, but we have ZK blockchains here, and we also should prove our innocence in that. So, okay, this is our plan right now. We work case by case. We create a common proving schema, the most efficient schema possible, and then we want to apply it to the multiple system with less effort. Yeah, I think that was all about my thing. And Proof of Innocence is in Gitcoin grants beta round right now. Yeah, if you want to contribute or if you want to tweet about it, please just scan the link and you will be redirected to the Gitcoin grants round. And if you want to learn about Chainway, you can just go to this QR and it will be redirected to our Twitter page. There is information about of our other products and, of course, the Gitcoin grants round. Yeah, I want to thank you to LPA and ETH Privacy Istanbul team for inviting me here. I was also attended the hackathon with Talip and Ömer Faruk. So yeah, it was a great experience for us, I think. And events like this happening in Istanbul will contribute to the Web3 ecosystem, we believe, because Web3 is not just about users, it's about developers, actually. And having a hackathon in Istanbul will, I think, onboard more developers to the Web3. I hope so. Yeah, if you have any question, I can take, and if not, this is all about my talk today.